Let me just share my screen. Just a second. Okay, is my screen visible? Yeah, okay, fine. So the first question is swap and flip. Okay, so the question says that given a binary string of length n, check if you can transform it to another binary string that is t. You can perform either of the two operations, that is pick I comma j that are distinct indices and swap si and sj, or else we can just flip that, choose two indices that are distinct and flip both the indices. That is, if it is 1, then convert it to 0, or if it is 0, then convert it to 1. Let's take an example. So let's say for this, okay. uh, so can anyone tell what operation can we do here? Either we can flip the bits, or we can swap the bits. Those are the two operations. Okay, for this one, I will explain it. For the further cases, you follow. Okay, so what is our first operation? Choose two indices. Choose two different indices and swap. That's our first operation. Or else, our second operation is choose two different indices and flip the bits. Okay, sorry. Okay, so here we can perform the second operation, that is choose two different indices, that is 0 and 1 in this case, and flip the bits. That is this. Okay, so this is currently our string s, and this is currently our string t. So we can just flip this according to the second operation, so it becomes 0 0. So we can convert this t into s or s into t. That's the case. So we have to just tell yes or no if we can perform this operation or not. We can convert this or not. Here in this case, can anyone tell, can we do it for this one? Yeah, anyone? Quick, quick.
No.
No, yeah, correct. You cannot choose two different indices and then perform one of these operations. It will either become like 1 0 or 0 1. That's the point. So the answer will be no in this case, as we can see. Okay, so how to solve this? The implementation was simple. What we can just do is we can check what are what indices that we have to change. Okay, if we have to change even number of indices, then it's yes or it's no. Okay, I will tell you, taking this example. Okay, so how many changes are required here? For the first index, change is required. Okay, for the second index, a change is required. For the third index, a change is required, and the fourth index, a change is required, because in the elements are different, right? It is 0, it is 1. We have to convert it. So total 4 changes are required, right? So this is a even count. So if you check for different cases, if it is an even count, then we can definitely convert it, like make it same. If it is an odd count, uh, that we just saw, this case. Okay, for this, for the first index we don't have to change anything. For the second index we have to change something. Okay, so the total changes are odd, that is 1. So we cannot make these changes. Even if it is 3 5, we cannot make it. So the answer is simple. Just check the indices and count plus plus. And if it the final count is even, then print yes, or else print no. Okay, should I implement it, or we should just move on? Yes, please. Okay. Okay. The second question is this construct permutation. So what this question tells is you are given an integer n, construct a permutation. Everyone knows permutation, right? Okay, I will tell. Simple. A permutation of size 5 is basically it contains 1 to 5 elements. 2, 3, 4, 5. None are repeated and there is no zero. Okay, it can be in any order. That is this. Okay, so this is a permutation of length 5. Similarly for n. Construct a permutation of P such that there does not exist I and J such that any subarray mod n plus 1 equals to 0. Informally, all subarray sums should not be divisible by n plus 1. Okay. If it is not possible, print minus 1. So let's look at example. So let's take this one, 3. Okay. So what they are trying to tell is you have to come up with a permutation such that uh, any subarray of this array should not be divisible by n plus 1, that is 3 plus 1 4 in this case. Okay, I will just write it down. So what are the subarrays possible in this? 1 1 2 1 2 3 and 2 3. Okay, so some of these subarrays, that is, for this it is 1, for this it is 3, for this one it is 6, for this one it is 5. All right. So is any of them divisible by 4? Everyone please answer. Is any of them divisible by 4?
No.
No, no, right. Okay. So this permutation is a valid permutation. Okay. So that's what the question says. That is you have to build a permutation such that any subarray should not be divisible by n plus 1. And if it is not possible, print minus 1. Okay. So if you observe carefully in this input only, as we can see, it is given minus 1 for n is equals to 2 and minus 1 for n is equals to 4. And if you check for n is equals to 6, which is a even n, then you will find out that for even numbers, it is not possible to construct such a permutation where this condition follows. Okay. So every time for even number, it will be minus 1. Okay. Uh, so what we got is if n is even, then print minus 1. Okay, now the case for odd. So let's take for 5. Can anyone tell any permutation that follows this condition? That is, any subarray is not divisible by n plus 1. Yeah. Is my question clear? Please answer. Okay, for this one, I will tell you. Okay, so the permutation, if you find out, is like 1, 4, 3, 2, 5. Okay, so for this, if we check, that is the 1, 4, 1, 4, 3, then 1, 4, 3, 2, 1, 4, 3, 2, 5, then 4, 3, 2, 5. Sorry, 4, 3. Just a sec. 4, 3, 3, 2, 3, 2, 5. Okay. If you sum any of this subarray, you will find out that None of them is divisible by what number? Yes, please answer.
5,
No, 6. We are checking for 6,
6,
right? Yeah.
and plus 1.
The question is given as n plus 1. Yeah. So if you check, no one is divisible by 6 here. So if we find out for like 7, that's what I tried. Like I found it for 5. What I found is 1, 4, 3, 2, 5. Then for 7, I found is 1, 6, 3, 4, 5, 2, 7. Yeah. So can you find the pattern in this? Yes, anyone? Can you find a pattern in this so that we can generalize it for other odd numbers? It is simple. Okay, so I will tell. Uh, what it is basically is if the numbers are odd, then it is basically 1, 3, 5, and then 7. Okay, and if the numbers are even, then it is 6, 4. So odd numbers are placed in ascending order, and even numbers are placed in between them in descending order. That's the pattern. If you check for this one as well, it is also true. 1, 4, 3, 2, 5. For 3, what was our answer previously? 1, 2, 3. For this, the odds are in ascending order, and then the evens are in, that is, descending order. Did everyone get this? Yes. Guys, please answer. If you are not getting it, then okay. Okay. Should I implement it? Yeah, should I implement it? Okay, move on. Okay, fine. Okay, some are saying I should. Okay, I will show you a quick implementation. It is just 1 or 2 lines, I guess. Let's say we are given just a number as an input. That is, this is our n. Then what we'll do is we will create an answer array of size n, that is a in this case. For I in range a, what we'll do is if I ampersand 1, that is if the index is even, sorry, odd. So what we'll do is ans of I equals to a minus I, else ans of I equals to I plus 1. And if I print ans, this will give you the implementation. Okay, just a second. Okay, and one more case, that is if a ampersand 1, then print minus, oops, 0, then print minus 1 and return. That's it. So that's the solution. Okay, did everyone get this? For even indices, that is for 0th index, we are placing 1, right? So it is 0 plus 1. And for second index, we are placing 7 minus I, that is 7, in this case 3 minus 2. Okay, let's move on. Now, what we'll do is, okay, then this one, Halloween array. There are n integers and a range L to R. Let f of a pi, this formula informally, f of a is the product of all pairwise XORs of the array A. If the resulting value lies between L and R, both inclusive, then print yes or else print no. That's the question. So let's take an example. This first one, yes, should work. Just a second, I will create a. Okay, so first integer is n, then L, and then R, and rest is the array. This is a two size array, and what they are asking is for every pair XOR, like every pairwise XOR, we have to take the product of them. That is, let's say, uh, 1, 2, 3, 4, 5. This is the array. So what we will do is we will take XOR of, uh, in case of like, let's take indices. Okay, we will take first index and then second index, and we will take first index, third index, and first index, fourth index, first index, fifth index. So these are the pair. Okay. So next pairs will be second index, third index, second index, fourth index. So whatever the XOR of these two values is, we have to product them for all these pairs. Did everyone get the question? Yes? Okay, fine. We have to consider pairs and then take XOR and then the product of them. Okay, now in this case, what is the XOR of 3 and 1? It is 2. Yeah, for 3 and 1, it is 2. So does 2 lie between 0 and 10?
Yes.
Yes. So the answer will be yes in this case. Similarly, for the second one, I guess for this one, the answer is again 2, but the range is 3 to 4. So here the answer will be no. So the basic intuition for this problem is we can just apply a brute force, right? We can iterate over all the pairs and then take product of them. But there's like it will get definitely get TL, right? Because it is 2 into 10 power 5 into 10 power 4, so it becomes high. Now what we can do is we can figure out some edge cases. Okay, so first edge case is the product will be 0 when. Yes, when will the product be 0? If any of the pair is 0, right? Yes or no?
when any element is repeating.
What? I didn't get it.
When any element is repeating, like
Yeah, so if any element is repeating, that is for like 2's or 2 is always 0, right? So if this 0 gets into our product, the entire product will be 0, right? Okay, so this is our base case that if there are repeating elements, then we will just check if 0 lies between L and R, and then we will continue. 0 lies between L and R, then print yes or print no. Else, what will be our next case? Okay, so let's say that every element is distinct. That is 2, 3, 4, 5, 6, 7. So here, every element is distinct. So you have to travels like n square times, right? The iterations will be n square. So here, what we can do is, if we can check a condition that if the product that we have calculated till now is greater than our R, we have ranges, right? L to R. So if the product is greater than R, we just print no and return. So this is the major case. Basically what happens is as we go on doing XOR and doing product, the product increases rapidly. So if we just put this condition in between the two loops, the number of iteration reduces. That's the thing. So should I implement it? Yes. Yeah. Should I implement it? Just answer something. Should I implement it? Okay, I will implement it. Okay. So what we are given is basically n. Uh, just ignore this template. Okay. This is just input template. Ignore these methods as well. We are given an array. We'll take the input. So this is our complete input, that is n, l, r, and array. So how will we determine if there are duplicate elements? Can anyone tell me our approach?
Put inside a set and check for the size. Is it
Yeah,
equal or not?
yeah, correct. So if so let's say duplicate is length of set of array. If duplicate, check if uh, l less than equals to l equals to 0, then print yes, else print no. Yes. Did everyone get this? What I have written? So what I did is I just converted this array input into a set, then calculated its length, and then put a conditional on it. That is, if it is less than n, then this conditional will basically assign the value as 1, or else it will be 0. Okay. And if the value is 1, that is our entire product will be 0, right? So the condition will be if L is equals to 0, then print yes, or else print no. Okay, did everyone get this? So this is basically finding duplicate. You can implement this anyway. We have to traverse over entire n. Then what we will do is, for every pair, what we are doing is saving a product. Okay, initialize the product to 1, and we are just taking xi or sorry, it is array of I or array of j. Okay, so if product is greater than our, print no, and break, else continue. If L less than equals to product less than equals to R. Okay, this was the major case, that if product is greater than R, print no. Okay, did everyone get the implementation? You can implement this anyway, just put this condition and that's it. Yes. Okay, fine. Let's move on. Does anyone have any doubt till now? Any doubt? Okay, let's move on. Okay, just a second. I guess this was the next question. That is connecting wells. Okay, so I will explain you the question. Just a second. I guess I have something. Is it here? Yeah, it is here. Okay, so what does the question say is, so there are n wells. Okay, wells are basically kuma. Okay, then the ith well is located at coordinated xi, yi, and there are n channels, one for each well. At time zero, all channels have a length zero, and the ith channel originates from the ith well. Every second, channel extends 1 unit outward from each well in four cardinal directions, that is north, east, south, west. When two expanding channels from different overlap or touch, the well are considered connected. Find the minimum time at which all wells become connected. Okay, between these questions, if you have any doubt, please ask. Okay, now what the question says is there are n wells. Okay, each well is located at some point xi yi. Okay, so the points are specified. Let's take for this test case. Okay, for this number of wells are 2 and points are 1 1 and 1 2. That is on the coordinate axis. If we see, mm, consider this is rough, but just go through this. Okay, for the time I will remove these points, just a sec. Okay, so according to this test case, I will take it up here. Points are 1 1, that is 1 1. Consider this star as a well. Okay, and 1 2. Okay, that is 1 and 2. Okay, so what the question says is there are also n channels that originate from each well. Okay, in the four cardinal directions. I will just open Excalibur, I guess. Just to make it simple. Okay. Uh, oops. Consider this. This is 1 1. This is, let's say, 2. This much is only needed. Okay, so this is one well, this is two, second well. Okay, so they say that every second a channel originates from the four directions of this well. For every well this happens, that is for this one as well. Every second 1 unit channel is created. So the question is, we have to connect all the channels, and what will be the minimum time required for connecting those channels? Okay, I will take a bigger example. Okay, just a second. Okay. Uh, okay. So consider these 4 points. That is, well is at 1 1, then 2 2, then 3 3, and then 6 3. That is this point. This stars specify wells. So for this well to connect, can the well be connected diagonally? Yes or no? Answer quickly. Yes. Are you getting the question or should I repeat? Okay, I will just repeat once. So there are n wells given. The location of those wells are also given. That is x, y, y coordinates. Okay. We have to connect these n wells through channels. Okay. Every second, a channel is originated from this left, right, up, down from every well. So that is for this consider. For the first second, this channel will be like here till 4. For the first second, from this, it will be something like this, right? So when these channels meet, the wells become connected. So we have to specify the minimum time required for this connection. for every well, obviously. That is, every well should be connected to each other. That is, this well should be connected to this one, then this one, then this one. This should be connected to this one, this one. Did everyone get the question? Now, should I repeat? Okay. Okay. Now, what happens is, answer one question. Can we connect diagonally? Can we connect this wells diagonally?
No,
No. Why? Because we
as
don't have a diagonal operation, right? The channels are originating left, right, up, down only. So if they meet, they will meet at a corner, right? That is from this one, right, and from this one, that is down. So here they will meet. So this is considered as a connection. So we have to connect these wells. Every second, this increases. That is, for the first second, this will be this. Then second one, this will be like this. Then the third one, this. So this is how the channels continue to grow. Okay, now, how will we solve this? Does anyone have any idea? How can we solve this? Can you relate this concept to anything? Okay, I will tell. Uh, so these are basically vertices of a graph. Consider this one as one vertex, and this one as one vertex, this one as one vertex, this one as one vertex. Okay, how many of you know what is minimum spanning tree? Okay, if anyone doesn't know, please raise your hand. I will explain it in short. Okay, I will just show you an example. What is minimum spanning tree? Oh, just a second. Oh. So consider this as a graph. Okay, so the tree will be, the minimum spanning tree will be consisting of the edges with the least amount of weight. Okay, so in this case, what is the least weight that you can see? Yes.
one.
Yeah, one. So this will be in our uh, graph, that is resulting graph, that is minimum spanning tree. Okay, one. Then second one, which one can you see? It will be this two, right? Basically, at the end, we have to connect all the nodes using this edges, and the edge weight should be minimum of all the trees. Okay, and the condition is there shouldn't be a cycle. In this case, there won't be actually. Okay, as you can see, the completed graph, that is this is the complete minimum spanning tree. Okay, as we go on connecting. Now, so this is what we have to accomplish in this problem. Yes or no? We have to connect these nodes such that we have minimum distance between them. Yes or no? Okay, if it is going above your head, then please. It is a bit tricky, so that's why. Okay, if at any point you have any doubt, please ask. Okay, so we have to finally connect these nodes such that they form a minimum spanning tree. Okay, and what will be the answer then? What will be the time required to connect these nodes? Okay, consider this one as the question. Okay, what will be the answer in this case? Finally, we have to calculate the minimum time at which all wells will become connected, right? Yes or no? So what will be the answer in this case? It is simple.
9.
Yeah, correct. It will be 9. So why 9? Because this will be the last edge that would be added to this graph, right? As we can see, previously the graph was like this, right? And at the end, we added this edge. So this was the total time required to connect this graph. Okay. Now that we know how to, what we have to accomplish, that is this. So I will show you the implementation, how I did it. Just a second. Okay, I will just copy this code. Okay, just ignore these comments. This is just testing. Okay, as Python is simple, just try to understand. I will explain you line by line. Okay, what I did was there are n wells. This is the input of this n wells, right? This is the test case input. Then n input. Then I have stored into a well list. In C++, this is vector kind of. Now, what I did was I appended this tuples, that is x and y, into this array. Then what I did was I calculated every possible uh, every possible distance. Now, how did I calculate it? Let's take an example. Okay, so let's say I have points 1, 1 and 1, 2. So what will be the distance between them? Yes, quick. Guys, please. What will be the distance between these 2 points? It's simple.
x1 minus x2 plus y1 minus y2.
Yeah, correct. So in this case, it will be 1, right? Now, what will be the distance between these 2 points? Now we can't take the diagonal distance. Okay, consider that and then tell the answer. What will be the distance between these 2 points?
2.
Yeah, correct. It will be 2. How? Okay, I will explain. Just a second. Where did I draw it? Okay, so this will be 1 point. That is okay. This is one distance, 1 unit, and this is 1 unit. Yes or no? So what we basically did was take out the maximum of them. Okay, for let's say 5 and 4, what will be the answer? For 2, 2, it was simple. For this one, what will the answer?
7.
No. Yeah, correct. Actually, sorry, it will be 7. And then we divide. Okay, fine. Uh, so that was like some point is at 1, 1, and then we just subtract this and this. So that's how we get it 7. Okay. So now what we have to do is we have to consider all these distances between every single pair. Okay, as we can see, the constraints are okay. The constraints are in 10 power 3. Okay, so what we will do is we will consider each and every point, that is loop over them and consider each and every distance that I just specified that. Okay, I will show you the C++ code actually if you're not getting it. Just, okay, so this is actually the input int n vector, and then id dot first and id dot second. Then we calculate the distance, that is dx, difference between the first coordinate of both the points and difference between the second coordinate of both the points. And then we take the weight as maximum of dx comma dy. So why this? So as I said, for 1 1 it is 5, for 1 1 and 5 4, what will be the distance? It will be 7, right? Yes or no? If this point wants to connect to this point, the distance will be 7. Okay, so if we divide this by 2, so why we are dividing by 2? uh, at every second, each well will grow its channel, right? So for, let's say, some channel is here and some channel is here. For every second, this will grow, and similarly for that second only, this will also grow. So they are trying to reach each other, right? Yes or no? So if they are trying to reach each other, then the distance will be half, right? Okay, let's say this point wants to reach this point, and the distance is between them is 7. So how much time will be required? 1 second, 1 unit channel is created. How much time will be required to connect these 2 points? Okay, did you get my question? There are 2 points at a distance of 7 units. Okay, at each second, a channel grows of 1 unit from these 2 points. That is from this point to the right, from this point to the left, right? So, how much time will be required to connect these 2 points? Okay, I guess you didn't get it. Okay, I will try to simplify it. Okay, these are 2 points, right? They are currently at a distance of 7 units. Okay, at each second, a line grows from this to the right. Okay, and from this to the left. So basically, they are covering distances. To this is covering to the left, this is covering to the right. So how much time will be required to cover this much distance?
I guess 4.
Yeah, answer is correct. It is basically divided by 2, but the seal value, right? Does anyone have doubt why will it be a seal value? Seal value is basically if it is 7 by 2, the integer value will be 3 and the seal value will be 4. At the 4th second, they both will overlap, right? In this case. So that's why we have to take the seal. Or else at the 3rd second, they will be 1 unit apart from each other, right? So this travels 3 units at 3 seconds. This travels 3 units from 3 seconds. Okay. And at the 4th second, both travel 1 unit. So that's when the connection is created. That's why the answer is seal of this if it is an odd number, or else if it is even, then it's fine. If it is, let's say the distance is 4, then it will just take 2 seconds. That is, this will cover 2 distance and this will cover 2 distance. Yes or no? Is everyone getting what I am saying? Yeah, okay. Now we have to calculate the distance between each and every point and consider it. That is, let's say this point is at 1 1 and this point is at 3 6 3, right? 6 comma 3, right? We have to calculate between each point how much distance we have to cover. At the end, uh, I will show you just a second. So let's say this is some point, this is some point, this is some point, and this is some point. Okay, just a second. Okay, so I will says this, this, this. I will try to connect each and every node. All right. So for this one, it will be for like this. This for this one, it will be like this. Let's take example in a Cartesian system, I guess. Then you will understand. For this, okay. So the first one can be connected like this, then this one can be connected like this, then this one can be connected also like this, then this one like this. This can be connected like this. Yes or no? We will consider each and every distance. Okay, we are given points, right? Just now we saw how to calculate distance between any 2 points. Now for any 2 points, we will calculate the distance. Just a second. Okay, sorry for the disturbance. For just now we have seen how to calculate distances, right? And we have also seen how to calculate a minimum spanning tree. So the idea is basically just calculate this each and every distance, that is this one, this one, this one, and then just consider the minimum ones that can connect both of the like the 4 of the vertices. Okay. Now everyone must have got it, I guess. Yeah, okay, fine. So basically calculate each and every distance and then we will remove as we go. Now let's move on to the implementation that we were doing. Okay, so as I said, it will be like if you check max of dx comma dy. So in this case, it was, so here basically I have written 2 conditions, okay, for like this one, let's say 1 1 and let's say 1 6. So in this case, it will be 6 minus 1, right? This component won't matter, right? So it will be 6 minus 1. So it is 5, right? But we have to take the seal value, that is plus 1 by 2. Simple, right? This much time will be required for these 2 points to connect. Yes or no? So similarly, if I take 1 1 and then 6 1, in this case the y coordinate is same. So similarly, 6 plus 6 minus 1 is 5. Again this 3 units of time will be required, right? Those are the 2 conditions that I have written. That is, if dx is 0 or dy is 0, then consider dx plus 1 by 2 as the weight of that edge, or else consider dy plus 1 by 2 if dx is 0. Or else it is kind of clear that if none of them is coming out to
Where
be
you put
0,
one?
that is Should I repeat? Okay, should I repeat?
Yes.
Okay. Uh, what I told is, okay, if there are 2 points, okay, and if any of the coordinate is same, that is the x coordinate of this 2 points is same, so the distance will be basically the y difference between the y coordinates. 6 minus that is 5, right? 6 minus 1, that is equals to 5, right? And how much time do I require to cover distance 5 between any 2 points?
Divided by 2.
Divided by 2, right? So we have to take the CL value, right?
Yes.
Yes. Did everyone get why we have to take the CL value? I just explained, right? Okay, I will just go through it once. Oh, okay. So let's say this one is 1 point and this one is 1 point, and difference between them is 7. Okay. So at third second, what distance this would have covered? 3 units, right? Yes or no?
Yes.
And at third second, this would have also covered three units, and 1 unit is only remaining, right, between them. And at the fourth second, they will meet. And if I just do divide by 2, it will be integer division, right? So it will come out to be 3. So to avoid this, we will just add 1 and divide by 2. So it will come out to be 4. So that's what I use here. So the difference between both of this will be 6 minus 1, that is 5. Then 5 plus 1 divided by 2, because 5 was odd, obviously. And if the distance was even, then this would not happen, obviously. Yes, did everyone get it? So let's say the point was 1117. Then what will be the answer? Yes, come on, quick.
3.
Yeah, correct. 3. Because the distance will come out to be like 7 minus 1, that is 6, and the final answer would be 6 plus 1 divided by 2. So that is 3, as this is an integer division. Okay, similarly for the y case, right? If y coordinates are same, these were the two cases, and if none of them are same, then what will be the distance? Now tell me. Everyone got this x and y part, right? Yes or no? If you give thumbs up only, then I won't understand. Just open your mic
Yes.
and say yes. Okay. Uh, for this one, what will I do? What will the x distance, that is dx? Dx distance will be 5 minus 1. That is equals to
4.
4. Dy distance will be 4 minus 1. That is equals to 3. Yes? Yes or no?
Yes. Yes.
So I have to calculate at least 4 distance in the x direction, or at least 3 distance in the y direction to reach this point. We will consider only the maximum one. Okay. You can check it like this only. Is there any doubt?
Why to choose maximum?
Okay. You can just. Okay. Where should I tell you? Okay. Let's say the point is at 5 and 3. Okay. Now, what distance will I require from to reach from this point, that is 1 comma 1, to this 5 comma 3? Okay, I will remove the rest of the points. Oops. Okay. What distance will be required? What time will be required? That is 1. This is 1, 2, 3, 4. Right. The points are currently, okay, I will mention the points as well. The points are currently 1, 1 and 5, 3. All right. Yes or no?
Yes.
Yeah. So this is 1, 2, 3, and 4. It has to travel at least 4 in the x direction and at least 3, at least 2 in the y direction. That is 2 and 3. Yes or no?
Yes.
Yes.
Yes. So if we consider this 5, that is 4 as our maximum distance, that time where will this be? Like traversing downwards. Okay, you didn't get my question, I guess. So I go on increasing till 5. Okay. So at time equals to t equals to 5 seconds, 4 seconds, where will this channel come to? Like this one. It would have traversed 4 distances, right? Below as well. So at time t equals to 4 seconds, they both will be connected. Or else if we consider t is equals to 2 seconds, then this would have just covered 2 distance, right? This channel. Yes or no?
Yes.
Yes.
Now, did you get it?
Yes.
Yes.
Yeah.
Yes.
Okay. Why to consider the maximum one? Okay. Now, so what I did was, okay, this will be a bit confusing. Okay, how many of you know what is priority queue? Everyone knows, right? What is priority queue? So this is a priority queue of pair of int comma int, and this is actually a mean heap. Mean heap is basically the smallest first. By default, priority queues are max heap. Okay. So what I do is basically push the weight that is the distance we have to traverse or the time required, and the coordinates that we are that is the points. So points basically I have just pushed in the indexes, that is 0 and 1, like 0, 1, 1, 2, 1, 3. I have not pushed the points. I will just refer to the indexes. Okay. So what we were basically doing is in this one, okay, I will show you through this. Okay. Now we have calculated all of this, right? Isn't it? Like this, we have calculated every single one, every single distance we have calculated right now. We have calculated from this to this, this to this, this to this. All right. Now, what we will do is we will try to form a minimum spanning tree. That is, remove some of the edges and just consider this ones. That will connect the entire component. That's the entire point, right? Yes or no? Yeah.
Yes.
So what I did was, okay, just a second. Okay. What we were considering the minimum edge weight, right? To come first. Yes or no? So in this, we consider the minimum one first, then the second minimum, then the third minimum. That is this one, I guess, 6 and 5. That's what my priority queue is doing, right? It will bring up the least weighted edge. Yes or no? And then we just have the points between which the edges are there. Are you getting it or no? Okay, I will just show you through a example, I guess. Okay, this is becoming too long. Okay, just I will try to finish it up quick. Okay, let's just comment out this part. So currently these are the points 1 5, 1 5, 4 3, and 2 4. Okay, so if I check what is in my priority queue, I will get this. That is, there is a distance of 1 between the 0 and the second point. That is this point and this point. Okay, then I have a distance of 2 between 1 and 2. That is 4, 4 3, and 2 4. I have a distance of 3 between 0 and 1. So as we can see, they are sorted according to the distances. Yes or no? Did everyone get what the priority queue is doing there? Yes or no? Yeah, okay, fine. Yes, everyone got it. Now, what further we do is we try to connect components. We did similar thing, right? We tried to connect two components. Firstly, we connected these two, then this, then we try to connect another vertices to the same component, right? We have to just connect them all at the end with the minimum tree. Okay, how many of you know what is a disjoint set? If you don't know, it's fine.
Yes.
You know what is disjoint set. Okay, I will tell you with an example. That is, let's say this is 1, 2, 3. They all belong to a set or a component. Okay, and this is 4 and this is 5. This is a set, another set. Okay, so these both are disjoint sets, right? Yes, consider them as nodes. Okay, 1, 2, 3, and these three are connected. Consider them as nodes, and these two are connected. Is 4 connected to 1? Obviously not, because they are disjoint sets, right? So what we will do is we will try to connect each and every component, and at the end get the final answer. Okay, this part is now quite tricky, so listen carefully. I will show you through an example only. What I did is, firstly, for each node, I have created a components array. Okay, components array. Consider a 4 size array. Then, what I did is, does this component, does this belong to this? So that's what I stored here. So currently we don't have anything. So the each vertex is parent of itself, right? So the 0th vertex will be parent of itself. Then the first vertex, that is, they are basically different components. That is, this is a different disjoint set. This is a different disjoint set. Different. And then this is different. All right. Then what I do is I will pop the minimum distance between. I will take the okay, through here. Okay, at the top, the minimum distance will be there. So I will take it, and what I will do is, let's say 1 and okay, let's say 1 and 0 gets connected. Okay, 1 and 0 gets connected. So what I will do is here I will just simply update this to 1. So that is, these two are now connected. Similarly, let's say if this gets connected to like this component entirely gets connected to 2, I will just update this part. This will be so this will remain 2, and this both will be updated. So at the end, what will happen is if all the 3 are connected, that is 2, 2, 2, and 2. Okay. Okay. Tell me one thing. How many edges do we require to connect this 3 nodes? How many edges do we require?
2.
Yes. The minimum number of edges required to connect 3 nodes is 2. Right? So once we do n minus 1 merges, just a second, that is, so for, I will show you, for 4, there should be at least 3 edges. So once we achieve n minus 1 merges, then we will basically break the loop and print the answer. So that's what I did here. I will share you this code, and then you try to like print it in between and see what is getting printed. And then you will recognize what is it exactly. Because if you don't try run it, you will not understand basically. It becomes hard. Okay. Did everyone at least get the question? Implementation is the rest of the part. Did actually okay. Then did you get what was our approach? Yes, we were just basically connecting the distances which are short, short, short. That is, we are building a minimum spanning tree. How did we calculate the distances? Did everyone get that? Yeah, exactly correct, Karthike. Yes, correct. When we actually connect n minus 1 edges, then we break out of the loop. That's the thing. And the final answer will be the edge weight of the final node that you just connected. As we can see, there are exactly n minus 1 edges in this as well. Yeah. So as soon as you connect the last node, the distance, the weight that you connected is your answer in the question as well, here as well. Okay. So does anyone have any doubt in these 4 questions? Yes, anyone? Okay, all right. So that's it for this PCD. Thank you for joining.